In this tutorial, we'll take a look at some basic relationships in probability. In a prior video, you have been introduced to the concepts of what's an experiment, what's an outcome, what's a sample space, what's an event. So those concepts should be clear by now, but now we are going to build up on those concepts into slightly more advanced ones. In particular, we are going to focus on events, and when we're going to look at union, intersection, and complements of events. So I'll first explain what these concepts are: union, intersection, and complement of events, and then we'll apply them to a problem setting and see how they are used to compute probabilities. So I'm going to draw some diagrams that you have probably seen in high school. So let's say you have a set of, I just call it S. This is equivalent to your sample space, you might think. This is the set of all undergraduate business students. So I draw a lot of dots. So each dot represents one undergraduate business student. So you know these are outcomes, and an event is a collection of outcomes. So let's identify two events. So I have event A and I have event B. So let's define what those events A and B are. A is an accounting undergraduate student. So, and B is the event that this student is, let's say, a marketing undergraduate student. So you can see that A and B are subsets of S. So obviously this doesn't account for all undergraduate students. So A, the circle A, if you think of all the dots inside circle A, they represent all the accounting undergraduate students. And all the dots within the circle B represent all the marketing undergraduate students. So here you have two events, A and B. So first let's identify what we mean by the union of A and B. So it's written A union B, also sometimes called A or B. This is called the inclusive OR. Okay, so A or B, if I had to shade, this is A and this is B. These are the two circles. So this shaded portion is A union B. Now notice that A union B is not the same as A plus B. So if I add the two circles together, I don't get A union B, because this middle portion I will be double counting. So it's useful to remember that. So if I had to say in words what A union B means, it means these are all the undergraduate students who are either accounting students or marketing students or both. That's what we mean by A union B. Now, similarly, if you have the two events A, B, and if I mark this middle portion over here, the overlap, and that's A intersection B, sometimes also called A, written as A and B. So again, in words, A intersection B in our specific example means all the students who are both accounting and marketing undergrads. That means these are double majors. Okay, and the last one that I will draw is, I'll just draw one event, in this case A, and I'll mark everything outside of A. Do you see? And that's called the complement AC, complement of A. So in words, complement of A would be all students who are not accounting students. So notice that this includes marketing, it includes a whole bunch of other majors perhaps, but these are all the students who are not accounting students. So this is what we mean by the union, intersection, and complement. Now moving on to some additional definitions. Let me scale up, try and keep this frame here. So I'll draw two more pictures. I'll draw them small. Here's A and B. So A minus B. Okay, so that's the shaded portion. So in words, what does A minus B mean? These are all the students who are accounting undergraduates but who are not marketing undergraduates. So from the accounting students, you have to take out the double majors. Alright, so A minus B means all the undergraduate students who are accounting students but who are not marketing students. Similarly, if here's A, here's B, if I shade this portion, this is B minus A. These are all the undergraduate students who are marketing students but who are not accounting students. Okay, so union, intersection, difference, and complement. These are the three operations that these are called Venn diagrams. I'm sure they should ring a bell from high school, but this is sort of the foundation that you need to apply to actually build up more complex probability calculations from the simple ones that we had discussed earlier, namely outcomes and events. Okay, so now we are combining events into more complex aggregations. Okay, all right, so let's take a specific example and we'll apply these concepts that we have just learned of union, intersection, difference, and so forth. So here we are told a survey of magazine subscribers shows that 45.8% rented a car during the past 12 months. 54% rented a car for personal reasons. 45.8 rented a car in the past 12 months for business reasons. 54% rented a car in the past 12 months for personal reasons. And 30% rented a car for both personal and business reasons. So using the picture that we had in the previous worksheet, so if this is my sample space of all my subscribers, magazine subscribers, and just for convenience, since we have 45.8%, let's say we have 1,000 subscribers. Okay, that means here is my event A. These are all my subscribers who rented a car in the past 12 months for business reasons. Okay, and event B, these are all my subscribers who during the past 12 months rented a car for personal reasons. So notice that I have overlapped the two circles because you can see in this last part it says that there are some subscribers who rented a car in the past 12 months for both personal and business reasons. So that means if I think of the circle A, there are 458 customers in the circle A, right? 45.8. That's why I took 1,000 customers instead of 100 customers. I didn't want to say 45.8 customers. So you have 1,000 subscribers. 458 of them rented a car for business reasons in the past 12 months. Similarly, if I look at event B, okay, so 54% rented a car for personal reasons. So there are 540 subscribers who rented a car for personal reasons. And then in the middle, you have these people. So you see 30%. So this middle portion is 300. Why 300? Because I'm taking 1,000 customers. 300 is 30% of 1,000. So the data is telling me that 30% rented a car for both personal and business reasons. So that's the middle portion. Now that we got this squared away, let's look at the first question. It says, what is the probability that a subscriber rented a car in the past 12 months for business or for personal reasons? So do you see it's asking for the probability of A union B, right? So if I quickly draw the two circles, here's A, here's B. These are the shaded portions. So how many subscribers do I have in this shaded portion? I have 458, which is the number of subscribers in circle A. I have 540, which is the number of subscribers in circle B. But if I simply add these two, I have double counted the middle. Do you see? This portion has been double counted if I simply leave it at this. So I need to take out the middle portion. So the middle portion is 300. So that leaves me with 998. I think that's 5,498. 998 minus 300 is equal to 698 subscribers. So the probability that a subscriber in the last 12 months rented a car for either personal reasons or business reasons is 698 divided by 1000, which is equal. So the probability, this probability that I'm looking for is 0.698. So let me generalize. So probability of A union B is equal to probability of A plus the probability of B minus the probability of A intersection B. Okay, so if you take this calculation that I just did, how did I get the 0.698? 458 divided by 1000. That is the probability of a customer renting a car for business reasons, and plus 540, sorry, divided by 1000. This is the probability of somebody renting a car purely for personal reasons, minus the intersection of the two. That's 300. Rented a car for both personal and business reasons. So minus 300 divided by 1000, and that will give you this particular number. Okay, so this is the general formula that I derived for you. The probability of the union of two events is the sum of the two probabilities minus the probability of the intersection. Okay, so let's look at question B. What is the probability that a subscriber did not rent a car during the past 12 months for either business or personal reasons? So let's shade, let's see what picture we get. So here's A, here is B. A is all the subscribers who rented a car for business reasons. B is all the subscribers who rented a car for personal reasons. So the question is that's being asked of us is, what is the probability that a subscriber did not rent a car during the past 12 months for either business or personal reasons? That means if I shade the area, it's this area, isn't it? These are all the subscribers who did not rent a car for either business or personal reasons. So if you look at this shaded portion here, do you see that it is just the complement of what we computed just now in A? Okay, so B, so I want the probability of not A union B. That means A union B is they rented a car for either personal or business reasons. That's the inside. When I put the not in front, it means I want the probability that they did not rent a car for either business or personal reasons. So that is this shaded area, so which is simply equal to 1 minus 0.698. That's the complement. Okay, is equal to 0.302. So the probability is 30%. So to generalize, the probability of the complement of an event is equal to 1 minus the probability of that event. Okay, so that's working with complements. Now let's look at part C. Part C says, what is the probability a subscriber rented a car for personal reasons but not for business reasons? Okay, so let's see again what the picture looks like. So this is part C. So here's A, here's B. A is all the subscribers who rented the car for business reasons. B is all the subscribers who rented for personal reasons. And part C says, what is the probability that the subscriber rented for personal but not for business? Okay. So they rented for personal but not for business. So I want this area. Right? So these are all the subscribers who rented for personal reasons but not for business reasons. So if I think of how many subscribers are there in that shaded portion, this is equal to the number of subscribers who rented for personal reasons, which is 540. You've seen that here. That's number of subscribers who rented for personal reasons is 540. And this middle, but this includes the middle also. This is all of B, isn't it? So I have to take out this portion, the middle portion, which is the people who rented for business reasons, and that is 300. So this shaded portion is 540 minus 300, which is equal to 240. So the probability is 240 divided by 1000, because there are 1000 subscribers in this box. Okay. So the probability of B minus A. Okay. So B is subscribers who rented a car for personal reasons, and A is subscribers who rented a car for business reasons. So B minus A is the shaded portion that I want. Okay, so this is simply equal to the probability of B minus the probability of B intersection A. Okay, so I think you can do part D on your own now. Part D says, what is the probability that a subscriber rented a car for business but not for personal? Okay, so that's fairly easy to do now. Here's D. See, here's my box. So I have 540 who was rented a car for personal reasons, and we had, how many did we have? We had 458 here, 458 subscribers, 458 subscribers who rented a car for business reasons, and this middle portion is 300, isn't it? We've already seen that. So in this case we want A minus B. So all the subscribers who rented a car for business reasons but not for personal reasons. So we have to take this middle portion out. So it is 458 minus 300, which is equal to 158. So the probability of A minus B is equal to 158 divided by 1000, which is equal to 0.158. Or if you, so this is the same thing as saying 458 divided by 1000 minus 300 divided by 1000. So if I had to generalize, the probability of A minus B is equal to probability of A minus the probability of A intersection B. This intersection B is simply this middle portion. This guy is the full circle A. So you subtract the two, you get this shaded portion. Just the portion that I want. So I've just introduced to you the concepts of union, intersection, difference of events. That's what we had seen in the previous sheet over here. Those are the concepts, and we applied them to a basic probability calculations, and we will work more problems like this in class. So this was a direct application of how you compute the probability of combinations of different events.